This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will fabricate the rectifier filter boards. I printed the strip board layout diagram, and I'm using it to measure off the two pieces of strip board I'm going to need for the rectification filtering boards. One board for internal power, the other for external. The boards are the same with the exception of one diode bridge and one capacitor less for the internal power supply. Now, I'm using an aviation shears to cut the strip board because I heard or saw, probably from someplace on YouTube, that the easy way to cut PCB printed circuit board is with aviation shears. So I got one of these metal shears and I decided to try it. What happens is you get a pretty good cut as long as the distance is essentially the same as the jaws, but as soon as you have to advance the shears, thick jaws need to be advanced. They crack and fracture the edges and veer the cut off from one direction or another. The end result is unpleasant. If I had to choose the worst tool to use for cutting printed circuit boards, and if I did not have a Dremel so-called saw around, then I would use this implement. But this is very clearly a failure. If the jaws were about 3 times longer, it might cut somewhat better. So here I am once more with a wire brush, cleaning a file, trying to file down these perf boards to get some semblance of a rectangle. Also, I need to smooth off the jagged, fractured parts of the edges, which are likely to fracture more and could affect the circuit. Luckily, I have nothing right up against the very edge, and so even if the strips were compromised, it would not substantially affect the end result. I didn't expect to be spending all this time playing with files. Although it's 3 or 4 minutes in this video, it's more than an hour. This is not fun. If I had used a razor saw, I would probably have been done with this in 10 minutes, but I just had to go with a new way to cut PCB board. The crossfades here are an artsy way to indicate that the time is marching on and it is not in sequence with what you're seeing on the screen. This vanilla paperboard really gets into the teeth of the file, and it needs to be cleaned very frequently. Epoxy fiberglass is a little bit better than this stuff in terms of not clogging up files. I believe I'm coming to an end of the filing, finally. What I'm going to do is take this transparency film. After cleaning the unclad side of the perf board, oh, it was more than 1 second that I had it propped up there. What I'm going to do is start laying out tape, and that tape is going to be used to try to stabilize the transparency film. It's printed off in such a way that it's reversed, so that the toner on the bottom, as in this case, will get transferred when I apply heat equivalent to the original heat of the laser drum. This should be stable. I'm putting a paper towel on top of this, actually 2 of them, to try to prevent transparency film from mucking up the iron. This is the first time I'm trying this as a labeling mechanism for printed circuit board. I'm giving this 6 minutes. And again, this is quite a long time, and I'm not going to subject anyone to 6 minutes. I had to pick up the iron because the iron is being very helpful, and if it sees it is sitting around in one position and it's apparently not picking up the motion, then it thinks I'm busy burning through the ironing board and the shirt and whatever else it is on. So it automatically cuts up, and I have to change the position of the iron to get it heating up again. I'm trying to apply heavy, consistent, flat pressure perpendicular to the surface of the strip board. And once again, as my creative, artsy crossfades. Still got 20 seconds to go on this 6-minute exposure to heat from the laundry iron. Now, an intervening period of about an hour, I allowed this thing to cool down. When I look at the results, well, some of the toner got transferred, but a lot of it stayed on that film. I let the thing cool down too much. Now I'm taking the second board, cleaned it off, set up some tape. I'm going to try to use a little less tape this time. I think part of the reason for the distortion of the image in the first try was it was taped on 3 sides. So why don't I have actually 4 sides? Now I've got my tape going, covered up with paper towel. The exposure is going to be the same, 6 minutes, starting now. But this time what I'm going to do is allow a lot less time for cooling after that 6-minute exposure to the heat. This go-round, as soon as that strip board is cool enough to touch, as soon as I can, I'm going to lift off the transparency film and see if I get a better transfer. The first one was not terribly good. There are 2 variables here. How long do you let the transparency film sit on the strip board? And the second variable is how long do you leave the iron on the strip board? And I'm using 6 minutes. I think the next time I try this, I'm going to bump up the exposure to 8. See what happens if I get a better transfer. Okay, halfway home. I don't know why this iron is pink. I think the Chinese believe that women prefer pink. Not the women I know. Also, my phone dims out every couple of minutes. I'm trying to apply a lot of pressure downward and perpendicular to the surface of the strip board. About finishing up here. I wonder, will it work any better this go around? Well, let's see. Exposure for 6 minutes, and just as soon as I can lift off the film, I'm going to lift it off. And the transfer is much better this time. It's still not perfect. I'm using a burnishing tool to see if I can improve the transfer. Yeah, it's clear the burnishing tool has absolutely no effect. But this is better, so we want to minimize the amount of time between applying heat and lifting the transparency film off, and maybe the next time I try this, I'm going to try it for 8 minutes instead of 6. I'm cleaning with isopropyl alcohol. Acetone would dissolve the toner. I did a number of trials. When the trials went wrong, I just removed the toner with acetone. Now let's see if we can't fix this up, improve the labeling a bit. I'm going to have quite a number of wires coming in and out of these things. It would be helpful to have accurate, readable labeling. Also, I need to know plus and minus for the diode bridges and for the capacitors. It would be rather embarrassing if I got the capacitor's polarity mixed up, or the diode polarity for that matter. I'd be picking pieces of capacitor out of my hands for days. I'm using a Sharpie ultra-fine point drying pen. It's supposed to be indelible. The second board doesn't need much correction, but the first board is now readable. In this video, I marked off and cut strip board to size using a metal shears, which was not the best of tools for the job. I spent a long time trying to flatten and repair metal-sheared, ragged, and fractured strip board edges. I transferred labels from laser printer transparency film to the unclad side of the strip board using a household laundry iron. In the next video, we will be continuing construction of the rectification and filtering modules. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.